Rust 1.73.0 was released today, October 5th, 2023, thanks to the hard work of hundreds of contributors. And what do we have today? A whole bunch of stuff. Number 1, cleaner panic messages. Before Rust 1.73, a panic message like this would emit a line like this, where the message was surrounded by single quotes and embedded in the middle of the panic output. In Rust 1.73, the message has been moved down to its own line, which is easier to read, since you don't have to find it in the middle of all the other panic output. This is an especially nice improvement for multi-line messages. But that's not all. The assert macro was outputting the same panic message as the panic macro and received the same improvement to the output. Even better, the assert equal and assert not equal macros had their output improved as well. Here is what the output of the assert equal macro looked like before. Notice how the assertion output is embedded in the middle of the panic output, and the assertion message is at the end of the assertion output, and there are lots of backticks surrounding values. Now the panic message is first, and the assertion output is second. Also, the assertion message has been moved to the end of the first line of the assertion output, and there are a lot less backticks. The assert not equal macro received the same treatment. Here's the before, and here's the after. Number 2, a better thread local API has been implemented for when your thread local value is wrapped in a cell or a ref cell. This should cover a lot of thread local use cases. Let's take a look. The thread local macro takes a static variable and wraps it in the local key struct, so the type of the variable things here is actually local key cell t. And before Rust 1.73, you had to call local keys with method and pass it a closure that would then access the underlying cell struct to call its methods such as get, set, take, and replace. Rust 1.73 adds a bunch of methods directly to local key when it is wrapping a cell or a ref cell, and these methods do the appropriate backend calls for you. That's much more ergonomic. As an added bonus, methods like set avoid unnecessarily initializing the thread local variable with the value from the macro before writing the new value that you pass to it, so it's also more efficient. Here's the full list of the new methods. For cell, there's get, set, take, and replace. For ref cell, there's with borrow mute, set, take, and replace. Normally I'd go over these in the stabilized API section, but since the blog post singled these out as one of the headliners, I did too. The entire new API is described in RFC 3184, so if you're interested, check that out. There's a link in the description below. Number 3, the clippy fun null check clippy lint has been uplifted into the Rust compiler as part of the useless pointer null checks lint. This lint checks to see if you are taking a function pointer and casting it to a raw pointer and then checking to see if it's null. This is a useless check because Rust doesn't allow function pointers to be null in the first place, so you might as well stop checking. Number 4, the no-op method call lint now warns by default instead of allows by default. This lint triggers for situations such as accidentally cloning a reference itself instead of cloning the reference's value, or when you accidentally double borrow a reference instead of doing a single borrow. Number 5, macros now support interpolating blocks for async blocks inside your macro rules macro. It looks like this. You can now pass a block to your macro, and then in your macro take that block and use it as the block value of an async block. This also now works for the unstable try block, but I doubt many people use the try block at all yet, much less in macros because it hasn't been stabilized. Number 6, the unconditional recursion lint now detects recursive drops. A recursive drop is when you trigger a drop of a value of a given type from within the drop handler for that very type, which is bad because then dropping one item of that type triggers an infinite recursion of drops. This can only happen in the first place if you're manually implementing the drop trait for your type. If you are doing that, this lint may help you out. Number 7, there's a new lint called co-inductive overlap incoherence, which warns when a recursive blanket trait implementation overlaps with another trait implementation, but the compiler is currently okay with it because it is using induction for overlap detection, which doesn't notice this. You should definitely pay attention to this warning if you see it because the plan is to switch the compiler to co-inductive overlap detection in the future, which will make this sort of situation a hard error. I'm talking about situations like this. Pause the video and puzzle this out if you want to. I'm not going to go any deeper because honestly, I'm not really a type theory guy, and I was lucky to figure this out at all, and I may very well have made a mistake in what I've described so far. But if I am understanding correctly, if we implement the specialization feature described in RFC 1210, then this code may actually work again, even with co-induction overlap detection. Or maybe I'm just completely lost. I'd say there's a 50-50 chance of either way. Someone smarter than me, please comment below and let me know. Number 8. The invalid reference casting lint was improved and was also switched from allow by default to deny by default. This lint detects when you use raw pointers in unsafe code to cast an immutable reference to a mutable reference, which is undefined behavior, even in unsafe code, so don't do it. I actually tried this code in Rust 1.72 just for fun on my Mac, and it crashed with a bus error at runtime. In Rust 1.73, you get a compiler error politely telling you to consider using an unsafe cell instead. Number 9. Apparently, GCC and LLVM write their version information to a special comment section of executables on Linux. Not wanting to be left out, Rust now does this too. You can view this information yourself by using the readelf command like this. Number 10. The v0 symbol mangling format has now been officially documented. Symbol mangling is how the Rust compiler encodes unique names for symbols that are used during code generation. Documenting exactly how this is done should make life much nicer for anyone who needs to demangle the symbols, like people who write debuggers. The documentation is located in the online Rust CBook, and I put a link to it in the description below. Number 11. The thiscall and thiscall-unwind ABIs have been stabilized. This ABI format places the C++ this parameter in the ECX CPU register on x86 in Windows, so when interoperating with C++ on Windows via FFI, this could be useful. Number 12. There are 7 new platform targets. Let's go through the list real quick. We've got 1 new Tier 2 platform target and 6 new Tier 3 platform targets. The Tier 2 target is WASM32 WASI Preview 1 threads. This target is for WebAssembly with the WebAssembly system interface and includes the new WebAssembly threads functionality. Obviously, given the name, this is the first preview of this target. Like always, I'm super excited to see progress on the WebAssembly front. The ability to deploy games I'm making to a browser as one of its targets still astounds me. I love it. Next, first up in our Tier 3 targets, we've got the TOS target on ARM64 processors. The only information I could find about this OS was the statement, TOS will open source in soon, by a person with a Huawei email address whose name was listed as this. Is this Mandarin? I don't know. So I guess it's a new OS from Huawei that's still in stealth mode. Then we've got a new C-Sky Linux target for the Chinese C-Sky CPU, followed by a new Android target on 64-bit RISC-V processors and another 64-bit RISC-V target, but this time for the Hermit Unikernel project from a university in Berlin, Germany. Then we've got a Unicraft target on 64-bit x86. Unicraft is apparently a joint project of a bunch of universities and companies. And finally, we've got a target for OpenHarmony on 64-bit x86, another Huawei operating system. If I'm counting correctly, this brings us up to 8 Tier 1 targets, 20 Tier 2 targets with host tools, 67 Tier 2 targets without host tools, and 127 Tier 3 targets for a whopping 222 total targets supported. Number 13, an ARC, or atomic reference counter, wrapping a file struct, now implements the read, write, and seek traits for convenience. Number 14, the standard IO empty struct already implemented the read trait. Now it implements the write trait as well, so you can use it whenever you need something that has empty reads and ignores all the writes to it, sort of like dev null. Number 15, standard process ExitStatus now implements the default trait, which is nice because before now there was no way to construct the ExitStatus struct outside of the standard library because it has private fields. Number 16, stabilized APIs. We already went over the thread local APIs that were stabilized, so we'll skip those. That leaves these ones to consider. First up, We have some methods added to all unsigned integer types, starting with divceil, which does integer division, rounding the result towards positive infinity, or the ceiling. Then we have next multiple of, which calculates the smallest value greater than or equal to an integer that is a multiple of the other integer. And finally, checked next multiple of, which is exactly the same as next multiple of, except that it returns an option none instead of panicking if the passed in number is 0 or the integer overflows during calculation. Next we have chown, which changes the owner and group of the specified path on Unix-like platforms, and its siblings, fchown, which takes a file descriptor instead of a path, and lchown, which takes a path, but if it sees a symbolic link, it will change the permissions of the link itself instead of the link's target. Number 17. The following APIs are now available to use in const contexts, so they can be evaluated at compile time. There's just 3 of them. First, you can create a weak reference counter, you can create a weak atomic reference counter, and the last is you can create a reference to a non-null struct. Number 18. Cargo now prints out environment variables when you enable extra verbose mode with -vv on your cargo run, cargo bench, and cargo test commands. Number 19. Did you know that you can create an HTML timing graph page when you run cargo build by adding the --timings option? Well, you can. And now this page displays the crates versions on the graph, which looks like this. I'm not sure why not all crates got version numbers. Maybe only crates that have duplicates in the list get version numbers? Or maybe it's a bug. Who knows? Number 20. The output for cargo help has been reorganized and colorized. The goal here is to make it easier to find what you're looking for in the help output. This was actually a massive update that affected the output of all the subcommands as well. For example, here's the new output for cargo run --help. Kudos to my friend Ed Page who did all the work here. Number 21. There are 20 new clippy lints. What is this, the golden age of clippy or something? These lints are growing like weeds. Let's go over them. Lint 1. Impossible comparisons. This deny by default lint checks for Boolean logic that will always evaluate to false, like this example that's looking for a status code that is both smaller than or equal to 400 and larger than 500 at the same time. Lint 2 is redundant comparisons, which is really similar to the last lint, but instead of looking for double comparisons that don't overlap at all, it looks for 2 comparisons where one is completely overlapped by the other. Like this one, where if something is smaller than or equal to 400, then it will always be smaller than 500 as well. Lint 3. Ignored unit patterns. This allow by default lint advises you to not ignore the unit type in patterns. It's usually better to be explicit that there is no data being ignored here. Lint 4. Read-only write lock. This allow by default lint alerts you when you take a write lock and then only use it for reading. This is way more expensive than taking a read lock. Lint 5. Filter map bool then. This warn by default lint warns you that nesting a bool then inside of a filter map method is slower and harder to read than doing your filter and map separately. Lint 6. Needless return with question mark. The try operator, or question mark operator, unwraps an OK variant of a result or returns an error variant of a result from a function. So if you apply the try operator to an error variant, you know it will return from the function. So you don't need the return keyword. Lint 7. Redundant guards. This warn by default lint checks for guard expressions that are doing pattern matching that could be done in the main pattern instead, and suggests you consolidate your pattern matching in the main pattern. Lint 8. Redundant locals. This deny by default lint just checks for when you shadow a variable with itself. Semantically, this is a no-op, but this can sometimes cause extra code to be generated, so it's better not to do it. Lint 9. Absolute paths. This allow by default lint recommends against using deep absolute paths. Instead, bring things into scope with a use statement. Lint 10. Error impl error. This allow by default lint checks for types named error. There's already a trait in the standard library named error. Naming your own thing error as well gets really confusing really fast. Lint 11. This deny by default lint checks for if you pass a 0 to an iterator's skip method. You probably meant to skip something, or if not, you should probably just remove the skip call. Lint 12. String lit cares any. This allow by default lint checks to see if you are iterating through a string of characters, checking if a single character matches any one of them, and recommends using a matches macro instead. Lint 13, 4 forward slashes. This warn by default lint checks to see if you accidentally used 4 slashes for your dot comment instead of 3 slashes. Lint 14, format collect. This warn by default lint checks for when you are mapping every element of an iterator into newly allocated strings and then collecting them together into a single string, and suggests using fold to append continuously to one string, avoiding all those unnecessary allocations. Lint 15, needless pass by ref mute. This allow by default lint checks to see if a mutable reference passed to a function is actually used mutably, and if it isn't, recommends changing it to an immutable reference. Lint 16, manual is infinite. This warn by default lint checks to see if you are manually re-implementing the isInfinite method for floating point numbers. There's a method for that. Lint 17, manual is finite. This is the same as the last lint, only for the isFinite method. Lint 18, manual partial ord and ord impl. This lint is missing from the website, so it's unclear to me whether it actually made it into this release. Moving on. Lint 19, read line without trim. This deny by default lint looks for attempts to parse a string gathered by the readline method without trimming the line first. This will always fail because readline emits strings with new lines, and the parse method can't handle new lines. It suggests using the trim end method to fix the problem. And finally, lint 20, type ID on box. This warn by default lint warns you when you call the type ID method on a box. You probably want the type ID of the thing inside the box. And to do that, you need to dereference down to the type first before calling the type ID method. Want to learn Rust? I teach Rust. Go to agileperception.com and sign up for the crash course, and I'll help you get started. Like and subscribe if you want more videos like this. See you next time, folks.